Okay, so now that we talked about the derivatives of trigonometric functions, let's try to put them to use, okay? So over here I wrote what they all were again, just so that we could use them when we try to get the derivatives of these four functions over here. So remember, the derivative of sine x is cosine x, the derivative of cosine of x is negative sine x, the derivative of the tangent of x is secant squared x, the derivative of the cosecant of x is negative cosecant x times cotangent x, the derivative of the secant of x is secant x times tan x, and the derivative of the cotangent of x is negative cosecant squared x. So let's try to get the derivatives of these four functions over here. So for the first one, we'll start off with y prime. So it's 2 sine x minus tan x is what y equals. So y prime would be just the derivative of this minus the derivative of this. So remember, 2 is that constant, so it's going to hang out front, okay? And then we want to know what is the derivative of sine x. So the derivative of sine x is cosine x. So we just put that there. Minus, and then what's the derivative of the tangent of x? We come over here and we say, that's secant squared x. And that's it. You're done. It was that straightforward. So the derivative of 2 sine x minus tan x is 2 cosine x minus secant squared x. Let's try the next one, number 2 over here. So over here we realize we're going to have to use the product rule, okay? The product rule to get the derivative. So we know that y prime is going to equal. Now remember, with the product rule, think of this as two different functions, okay? And it's just the first one times the derivative of the second plus the second one times the derivative of the first. Now remember, because it's the product rule and because it's commutative, if you had done, the derivative of the first times the second plus the derivative of the second times the first, that would be the same thing, okay? So let's just do this way, the first times the derivative of the second. So it's going to be x times, and then the derivative of secant x is secant x tan x. Plus, and then since we did this function and the derivative of this one, we're going to flip-flop it, and now we're going to take the second function, secant x, and we're going to multiply it by the derivative of the first, and the derivative of x is just 1, so it's actually just going to stay at secant x. So then we can just write it a little nicer, because I'm not going to put that times there. I was just showing you to help you through it, but now we'll just write it as x secant x tan x plus secant x. Done. Okay. Now let's try this third one right here. Okay. So for this one, we're going to take the derivative of this and then the derivative of this. So it's going to be y prime equals the derivative of 3x is 3 plus, now remember, again, this is product rule. Okay, so we talked about the product rule over here. So we'll just do, and I'm going to put this in parentheses just so you can see that we're doing a separate thing. In the end, we're not going to have to worry about it, but let's just put it in there for now. So it's going to be x times the derivative of tangent, which is secant squared x, plus, okay, the derivative of tangent, tangent times the derivative of x. So tangent times the derivative of x, which is just 1. So we're done, that's it. So it's just going to be, now I always like to put this constant last. You may in books, or you may have other teachers that say, you can leave the constant first. I always like to toss that constant last. So I'm just going to reorder this to have it be x. Because this is plus, again, these parentheses aren't going to matter. Okay? So it's going to be x secant squared x plus tan x plus 3. Okay? So y prime is x secant squared x plus tan x plus 3. Okay. Now on to the last one. The last one is quotient rule. So this one I am going to kind of show up because quotient rule is a little bit more complicated than product rule. So remember what I taught you. I said identify your numerator as the function f of x and your denominator as the function g of x and write them down. So f of x is going to be x. And then remember, you have to write its derivative down as well. So f prime of x is 1. Okay? G of x is going to be the denominator, which is 1 plus the cosine of x. And then g prime of x is going to be the derivative of 1 is 0, so that doesn't matter. And then the derivative of cosine, as you remember, is negative sine. So negative sine x. Good. Now remember, we talked about this times this minus this times this over that squared. So in this case, it's going to be 1 times 1 plus the cosine of x minus x times this, so minus x times negative sine x over, and then remember it's g of x squared, so 1 plus the cosine of x squared. Okay, so now I'm kind of running out of room, so what I'm going to do is I'm going to erase this problem. We're going to come back this way. Okay, so now let's come back up kind of this way to finish this out. So obviously 1 times that's just going to stay, so 1 plus the cosine of x. And then now we've got minus x times negative, so that's actually going to become a plus, and then it's going to be x sine x, okay? And then all over 1 plus cosine x squared, okay? So that's going to be your derivative of this function here, y equals x over 1 plus the cosine of x, okay? Now, some people may want you to multiply this through, you know what I mean? Like, you don't have to, you could leave it this way. So just listen to whatever your teacher says. For me, I would actually be okay with you leaving it that way. Good, so that's it. So I want you to work on the problems that I assigned that look kind of like these. You now know the derivatives of your trig functions, and you have them over here. You have them in the book, okay? And I will see you next week.